Hi, best friend. This is, of course, I'm Teacher Julie.
I'm Teacher Jazz. Hi. Hi, hello everyone. Welcome back to our channel. And for today, we have a new lesson. But before that,
Of course.
oops, may hugot ako sa'yo.
Ano yung best?
Geometry ka ba?
Bakit?
Kasi, kahit anong angle, ang ganda-ganda mo.
Best friend nga kita.
Pizza mamaya, pizza.
Yung toppings lang, bigay ko sa'yo later.
Inot. Alright.
Ako, may hugot din ako sa'yo.
Talaga lang ha? Okay.
Oo, hugot din ako. Alam nga,
Kaya ano yan?
Infinity ka ba?
Infinity? Bakit?
Kasi, hindi nauubos ang ganda mo.
Nakuha mo. So much for that.
Are you ready?
Are you ready for our lesson today?
Okay. So, our lesson for today will be about sum of finite and infinite geometric sequence.
Right! Bring it on, sister!
Okay, thank you, best friend, everyone. This will be our topic for today, sum of finite and infinite geometric sequence. And the two formulas here will be the formulas in finding the sum of a finite geometric sequence. So we have sum of n terms is equals to a sub 1 minus a sub 1 r raised to n all over 1 minus r. Or we can have sum of n terms is equals to a sub 1 minus a sub n times r all over 1 minus r. Wherein r here should not be equal to 1. And the third formula will be the sum to infinity, and we can use this one if our geometric sequence is an infinite geometric sequence. So our formula will be a sub 1 all over 1 minus r.
For example, find the sum of the first 20 terms of the sequence 5, negative 5, 5, negative 5, so on and so forth. But before we can answer this one, we have to know first if this is a geometric sequence. When you say geometric sequence, they have a common ratio. Does this sequence have a common ratio? Absolutely. Yes. Their common ratio is negative 1. Negative 1, take note, 5 times negative 1 is negative 5, times negative 1 is positive 5, times negative 1 you get negative 5. So therefore, this is a geometric sequence. Since this is a geometric sequence, we have to know first if this is a finite geometric or an infinite geometric sequence. When we say finite geometric sequence, it has a last term. Does this sequence indicates that it has a last term? Absolutely, because we are only going to look for the sum of the first 20 terms. So there will be 20 terms of this sequence. So it is a finite geometric sequence. And since it is a finite geometric sequence, we have two formulas, but we are not going to use that one. And why? Take note. We are not going to use the formula that I presented to you a while ago because the common ratio is negative 1. I repeat, do not use the formula I gave you a while ago because the ratio is negative 1. So what are we going to do if the ratio is negative 1? Automatically, we are going to use our sum of how many terms? Sum of 20 terms. Take note, you are going to add only 5 minus 5 plus 5 minus 5 plus 5 minus 5 plus 5 until 20 terms. So automatically, if the ratio is negative 1 and the number of terms is even, when we say even, there are pares 20 terms, so it's even. Automatically, the sum of 20 terms is 0. What if it's not an even number of terms? How about if I will be asking for Find the sum of the first 25 terms. Still the same sequence. 5, negative 5, 5, negative 5, so on and so forth. And then it asks for the sum of the first 25 terms. The same, the common ratio is very good. It's still the same, negative 1. But the number of terms, is it even? Is 25 an even number? No, it's an odd number. Therefore, to get the sum of 25 terms, since there are 25 terms, we're going to get the sum of 25 terms. Automatically, the answer is only the first term. I repeat, the answer is only the first term. So, what is our first term here? Our first term is very good. It's 5. And that's how we get the sum if the ratio is negative 1 and the number of terms is odd number. Okay, let's take example number 2. Find the sum of the first 30 terms of the sequence. Negative 3, negative 3, negative 3, negative 3, so on and so forth. First question, is this a geometric sequence? Very good. It's a geometric sequence with a common ratio of, absolutely, it's 1. So since the common ratio is 1, we are going to identify our sequence if it's a finite geometric sequence or an infinite geometric sequence. If you are going to notice, it gives you a 30 terms, sum of the first 30 terms. So automatically, we have a last term. So since we have a last term, then this is a finite geometric sequence. So if it's a finite geometric sequence, are we going to use the formula that we have a while ago? The answer is no. Why no? Because it will take us a very long time. There's a shortcut if we have this kind of problem. All you have to do, if this is the kind of problem, you just get the sum of how many terms? 30. And how are we going to get the sum of this one? You just multiply our first term. Do you know the first term? Multiply our first term by the number of terms. And that's it. We get now the sum of our 30 terms of our geometric sequence. I repeat, just get the first term. Our first term is negative 3 multiplied by n. How many terms we have here? We have 30. So just multiply it by 30. So answer, negative 3 times 30. The answer is negative 90. So negative 90 is the sum of the 30 terms, of the first 30 terms of the sequence, geometric sequence, negative 3, negative 3, negative 3, negative 3, so on and so forth. Okay, so are you still awake? I hope so. We still have example number 3 going on the way. So have this one. Find the sum of the first 6 terms of the geometric sequence with first term 40 and common ratio of 1/2. So in this kind of problem, this is the time that we are going to use our formula. Since, again, it asks for the sum of the first 6 terms, automatically this is a finite geometric sequence. And we will be using the formula that I gave you a while ago. I have given you 2 formulas. So which of the 2 formulas are we going to use? We have to identify first what are given here. So we will know what will be our formula that we will use. So identify our given. So do we have first term? Yes, with first term of 40. Do we have last term, a sub n? No, we don't have a last term. So do we have a common ratio for r? Yes, and a common ratio of 1/2. Do we have n number of terms? Yes, because find the sum of the first 6 terms. So the number of terms that we have 6 terms. So These are our given, and then we will be using our formula. So the first formula, I'm going to show it to you right now. Formula here, the first formula that we have for finite geometric sequence can be used if we have first term, common ratio, and number of terms. And the second formula that we have, we can only use this one if we have first term, we have last term, and we have common ratio. So based on these two formulas that we have, which do you think we're going to use? Absolutely. We will be using our first formula because we have first term in our problem, we have common ratio in our problem, we have number of terms in our given problem. But we don't have last term, so we are not going to use the second formula. So we will be utilizing our second formula. So what is again our second formula? Or rather our first formula. So we'll have sum of n terms is equals to first term minus first term times r raised to the power of n all over 1 minus r. With this formula, we can now substitute all the variables that are unknown. So this will be the sum of how many terms? Yes, the sum of 6 terms equals. First term is 40, so this will become 40 minus 40 again, multiplied by common ratio, which is 1/2, raised to the power of n, which is 6, all over 1 minus the common ratio, which is 1/2. Next, since we have already this one, we have to remember in simplifying, we always apply PEMDAS. What is PEMDAS? When we say PEMDAS, we have to simplify first those who are inside the parentheses first, followed by the exponential, take note, and that's the time you can multiply or divide, whichever comes first, and then addition and subtraction. So we'll just copy sum of 6 terms. So therefore, can we subtract 40 minus 40? Absolutely not. We just copy 40 minus, can we multiply 40 times 1/2? Still, we cannot multiply because 1/2 has an exponential of 6, has an exponent of 6. So this will be copied for 40 times. So we have to simplify first, 1/2 raised to the power of 6. So what does it mean? It does not mean 1/2 times 6. That means 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. It means we have to multiply 1/2 by itself 6 times. So 1/2 raised to the power of 6, that's equivalent to 1 over 64. All over, can we subtract 1 minus 1/2? Yes, because they're all alone in the denominator. So you can subtract. So 1 minus 1/2, the answer is 1/2. So after that one, since we are done with simplifying our exponential form, then we can do the multiplication. So 40 minus 40, we cannot simplify that one yet, so we just copy again 40 minus, but we can multiply 40 times 1 over 64. So that will become 40 over 64, all over 1/2. If you're going to notice, our fraction is very big. We can reduce this one to lowest term. So to make it easier, 40 divided by 64 can be reduced to what? Yes, they have a common factor of 8. So 40 divides 8, we have here 5. 64 divides 8, we have 8. So 40 over 64 can be reduced to 5/8. So continue here. So we'll have sum of 6 terms is equals to, so this will become 40 minus 5 over 8. Since this is a whole number subtracted by a fraction, then you are going to use, we get the LCD. So the LCD here is 8. And then the 40 here, it's a whole number. It has a denominator of 1. So our LCD is 8, so 8 divided by the denominator here, multiplied by 40. So 8 divides 1 is 8 times 40, that's 320. Next, 8
divided by 8, still 1 times negative 5. So this is still negative 5. All over 1/2. Simplifying 320 minus 5. So we'll do the hard way. So this will become, yes, that's 315 divided by 8 divides 1/2. So fraction divided by a fraction, we can have that one as 315 over 8 multiplied by. So this divided by will become multiplication. Get the reciprocal of 1 over 2. That is 2 over 1. So this will become 315 over 8 times 2 over 1. Multiplication of fraction, numerator times numerator, denominator times denominator. Or we can reduce first those numbers that have a common factor, and that is 2 and 8. So we divide first 2 and 8 by, yes, they can be divided by a common factor, which is 2. So 2 divided by 2 is 1. 8 divides by 2 is 4. So final answer, numerator times numerator. So 315 times 1, that is 315 all over denominator times denominator. 4 times 1, we get our answer 4. 315 over 4, that will be the sum of our first 6 terms of a geometric sequence whose first term is 40 and a common ratio of 1/2. Now we'll go to example number 4, the one that you have been waiting for. What is the sum to infinity of 1/2, 1/4, 1/8, 1 over 16, and so on and so forth? So again, sum to infinity. So it's very clear here. We are going to look for the sum to infinity. And if it's an infinity, sum to infinity, then our formula will only be first term all over 1 minus r. Do we have last term in the given problem or situation? Take note. We don't have the last term on this example. So therefore, it's really sum to infinity. You only have to get the first term and the common ratio. So given. So what's our first term? Our first term is, yes, our first term is 1/2. What is our common ratio? Yes, how are we going to get our common ratio if it's hard? Yes, you have to divide our second term divided by our first term. Oh, it's a fraction divided by a fraction. So we'll do this. This will become, copy our first fraction, and then it will be multiplication. You are going to get the reciprocal of the second fraction. So 1/2 will become 2 over 1. That's it. Equals. So, numerator times numerator, denominator times denominator. Or, you can reduce first our numbers, those who have a common factor. If you're going to notice, we have 2 in the numerator and we have 4 in the denominator. So, we can divide out. Yes, we can divide out 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So, that's it. Numerator times numerator, 1 times 1, the answer is 1. All over 2 times 1, denominator times denominator is 2. Therefore, our common ratio is 1/2. So, we have first term and a common ratio. Then, we can now simplify our answer, sum to infinity. First term, substitute, that is 1/2. Divided by 1 minus, what's our common ratio? Our common ratio is 1/2. After doing the substitution, we can now simplify. So the numerator cannot be simplified, so we just copy the numerator, which is 1/2, and then we subtract 1 minus 1/2. Of course, answer is 1/2. Last but not the least, 1/2 divides 1/2. If you want to do the shortcut, you can go directly, divides out 1/2 by 1/2. So, 1/2 divides 1/2, the answer is 1. 1 divides, so the answer is 1. So, the sum to infinity of the given infinite sequence, 1/2, 1/4, 1/8, 1 over 16, and so on and so forth is 1. So, that's it. Very easy, right? Okay. Take note.
we can only get the sum to infinity of a geometric sequence if and only if the common ratio is greater than -1 but less than 1. So in this example, our ratio is 1/2. It's greater than -1 but less than 1. So I repeat again, we can get the sum to infinity if the common ratio is greater than -1 but less than 1. So, what if our problem asks for the common ratio is 5? Does the common ratio here applicable? No. So the answer will be the sum to infinity does not exist. I repeat. So if the common ratio is above this range, so your answer will be the sum to infinity does not exist because we cannot compute it. Do you get that? Okay, that's it for today, guys. Our lesson all about sum of finite and infinite geometric sequence.
Yes. So thank you so much for listening or for viewing us. And we have a good
Yes,
news.
we have a
We'll be giving out 3 loads, 50 pesos each for 3 students for our followers and viewers.
Repeat, only students. Exclusive for students, ha?
For your loads. For those who can give us
Pinakaastig
na hugot
Yes.
regarding our lesson for today.
about geometric sequence.
Just like what we gave you earlier, right?
So, please write it down on the comment box.
Yes.
Your pinakaastig na hugot. And we will be looking at it, you know.
Then we will reach you out to give you the load.
Don't forget to subscribe our video and we'll be doing a lot for you also, guys.
Yes.
Thank you.